Good morning, good afternoon, good evening. Today I'll be showing how to make a node group to allow word-wide text operation with geometry nodes. Currently, as of Blender 4.4, by default we can control text per character using instance index or per line using line index. However, in most Western languages, the smallest meaningful element of a text usually is a word, and not being able to control text animation on word bases is a problem in my opinion. The node group we'll be making will assign word index, allowing us to control text on word bases. It should be a quite useful tool, so I implore you to watch till the end. Alright, let's get into it. As soon as we get into Blender, let's hop right into Geometry Nodes Layout. A to select all, X to delete. Shift A, add mesh plane. Using numpad 7 and 5, go into top orthographic view. Click on New, delete group input, and replace it with string input. We'll be using multiple words today, so I'll type in "this is a test." Pass it through strings to curve, then output. So the objective is to control words as unit. To do so, we'll want to split the text based on white space and assign incremental ID to each word. In this case, this will be 0, is will be 1, so forth and so on. The first thing we'll do is identify the white spaces. When I say white space, this includes single space, tabs, and new line characters. If we take a look at the spreadsheet, white space instances lack this geometry symbol. This signifies that there is an instance container assigned to that ID, but geometry itself is empty. We'll use this to our advantage. So let's extract each letter instance and evaluate it. Add a separate geometry, set domain to instance, and connect curve instances. Connect a compare equal to selection, then index to A. We can examine each letter by changing this B value. When we realize this instance, any valid letter will have one or more spline to its geometry, whereas space will not. So connect the domain size and change component to curve. Connect a compare equal to spline count and compare with 0. If the result is true, it should be a white space. Let's select these nodes and Ctrl G to make a node group. Connect the result to output. We'll also connect the B to input and rename it to instance pause. Tab out and rename the group to judge white space. So now that we have a way to identify white spaces, let's determine how to set word index. What I'll do is iterate through each instance. Evaluate if the current instance and the next one is a white space, and increment word index at its specific pattern. So starting with T and H are both not white space, so move on to H and I. When we reach the space after S, we have a case that the current instance is a space and next one is not. This is where we want to increment the index. I hope this makes sense. Okay, so first we need a repeat zone. Disconnect and reconnect like so. Next, for iteration count, we want the total count of letter instances. Branch out domain size and set the component to instance, then connect to iterations. Next, we want a variable to keep track of the word index, so select the repeat node. In the side panel, select the node tab and add a repeat item. Call it word index with integer type. Okay, we are now ready to add some nodes. We want to check both the current and next instance for white space each iteration. So, connect the geometry to judge white space, and also iteration to instance pause. This will be for the current instance. Ctrl-Shift-D to duplicate with connections. Then, insert an integer mask and add 1. This will be for the next instance. Now the pattern we want to find is which current is a white space and next is not. So connect the boolean not to the bottom and AND it with the top. Now add the result with word index. I'll just cut corners and add the boolean result directly. Then store it by connecting add result to repeat output. We're done incrementing the word index, so let's store them in our instance. All instances will hold a word ID, and we'll set -1 in case of white space. So start by adding a store named attribute. Then change option to integer instance and call it WID. We only want to update the current instance pointed by the iteration. So from selection, connect the compare equal with index, then connect iteration to B. Next, from the top judge white space, branch a switch. Change the input type to integer and connect word index to false. We'll set -1 when the white space is true. Then connect to store named attribute. And that's it. Let's go to the spreadsheet and see how the WID is set. As you can see, all instances are now assigned WID value, with this being 0, is being 1, and white space being -1. I'll just grab these nodes and Ctrl G to group them. Let me just clean it up a bit. There's a lot of noodles, but I'll try my best to make it presentable. Okay, hope this clarifies the connections better. Let's tab out and call this set word index. Alright, I'll just make a simple animation to demonstrate how to use this. For this animation, I'll make each word drop down sequentially from the top to readable position. Add a set position. Pull out a combine XYZ from offset. Then map range from Y. I'll drive this map range with scene time. Add a named attribute with WID we made. Then connect to from min. Add 1 and connect to from max. Set the initial Y offset to 3 so they start off out of the view. Then set to max to 0 so they end up at the original position. Now when we animate, text will drop down word by word. We can also use this to differentiate word color as well. Let's just quickly convert to mesh with fill curve and set material. We'll just use the default one. Split open a shader editor, then select the default material. I'll just use the HSV node for simplicity's sake. Specify some color and add an attribute node. Change the attribute type to instancer and type in WID. Divide the factor by 4, then connect to hue. When we look at the material preview, we can now see that each word has its own color. Last point I want to address is that since this node group iterates through the whole text, it might cause processing load to go up when used on very long string. In that case, I'd advise you to add a bake node and bake the first frame, since the WID should not change dynamically. This should suppress the calculation load. Okay, let's just go over the final node tree. Top layer can be anything, but the important part is this set word index. And here's the judged white space. So that's it for this video. As mentioned in the beginning, I assume there should be a lot of demand for such functionality. I hope in the future there will be a built-in default option to do what this node group does. But until then, I advise viewers to keep this as an asset to utilize in text animations. Thank you for watching, and see you in the next one.